Hi, buddy. This is Mr. Folly, and welcome to podcast 2.1. We're going to talk about types of matter and how we identify them. So, types of matter. There are pure substances, and remember, substance is a fancy word for stuff, so we get through this. So, pure substance, 100% pure cowboy, or mixtures, which is a blend of different things. Okay, so something is either pure or a mixture. Okay, and a substance is a fancy word for stuff. Elements are, I suppose I should stop this now, huh? Elements are pure. Every atom of an element has the same property of other atoms of an element. So notice we're going to have the same properties. Okay, helium in Indiana is still light, clear, and makes your voice sound funny. Some elements are diatomic. So what this means is they're never found by themselves. You never see H by itself. H is either H2. O is never by itself. It's always O2, N2, Cl2, etc. But if I have something like carbon monoxide, that's okay because oxygen's not by itself, it's bonded to carbon. So this is diatomic, and that means there's twos when they are not attached to other elements. Ding. Definitions. Atom, smallest part of an element that retains the properties of that element. Molecule, smallest part of a compound that retains the properties of that compound. Now we know water is H2O. And maybe you know water looks like Mickey Mouse. Okay. If I split it off, if I get to this part, then I have OH, which does not have the same properties as water. Okay. But one molecule of water will still have the same boiling point. These are just examples of properties. The same density. And same other physical properties will still be transparent. You can see through it. Same thing is true for an atom like gold. So if I have gold and a chunk of gold, I can keep cutting it and cutting it and cutting it smaller and smaller and smaller. And there comes a time where if you cut it any smaller, it won't be gold anymore. Compounds are pure. Even though they have multiple parts, the combination is pure because it has unique properties to its component, meaning what it's made up of, component atoms or parts. Okay. In other words, water is H2O. If you light hydrogen on fire, it goes boom. If you light oxygen on fire, it goes flash. If you put water on fire, it goes out. Every sample will have identical intensive properties to any other. And that's like the boiling point stuff. So I just talked about how water is different. Na. If you eat sodium metal, it will kill you. It's poison. It will burst into flames and light you on fire. Chlorine is a deadly gas. But if you don't have salt in your diet, we hear about having too much salt. If you don't have any salt in your diet, you die. So it is essential as a compound, but killer in its parts. The smallest particle of a compound is a molecule, which we just saw the definitions. Mixtures have a blend of properties. Each part retains its properties. Salad, carrots, lettuce, honey mustard, honey mustard. So notice how all those parts are still there. Salt water, tastes salty, is wet. Both properties are there. Blood. Blood is a mixture. Carries blood, all those other things. There's a good blood picture. Blood has a certain consistency and its different parts that it's made up of. We'll do those things. Homogeneous mixtures. Every sample is the same. Homo means same. What's the same? The samples are the same. It's also known as a solution, meaning that's a synonym for it. Most any state of matter of mixture is possible. Solid in a liquid. Liquid in a liquid. So solid in a liquid, salt water. Liquid in a liquid, I can't think of anything that isn't like, let's see, liquid in a liquid. Ethanol and water. Gas in a liquid, carbonated drink. Gas in a solid is really rare. I couldn't even give you an example that makes sense to you. And an alloy is a solid in a solid. And in this case, it'll be two metals for an alloy. Alloys, by the way, are always homogeneous. The other ones don't have to be. Heterogeneous mixture. Hetero means different. So what's different? The samples are different. It's usually obvious, like you can see chunks of things. So like here, do you see there's different parts? Yes. Oops, I don't want to do that. I jumped too soon. Living things have cells, and if I look at my cells, so they are hetero. Anything that has cells or proteins in it's heterogeneous. See the different parts? Look, that's clearly a different part. See the different parts? Oh, that's a cell. See the different parts. Look, these are different parts. This is the umbrella section. What a fancy umbrella for this thing. Is it an element, a compound, homogeneous mixture, heterogeneous mixture, and why? So let's take a look. Iron. Okay, so it's an element if it's on the periodic table. On periodic table. Okay, and it's pure. Air. It's a mixture. Gas is almost always form homogeneous mixture. It's a homogeneous mixture of oxygen that we breathe and CO2. We know it's homogeneous because when I go, I get the same amount of oxygen every time. Rust is a compound because new properties of compared to iron and oxygen. 14-karat gold is a homogeneous mixture of two solid metals. Remember, whenever you mix two solid metals, you get an alloy which is homogeneous. Steel, again, we're mixing metals. They're homogeneous mixtures. And then see this answer here. Diamond is pure carbon. And pure carbon is an element. Ding. Blood. Living things. Hetero. Coal is a mixture because it's impure. And we talk about all the nasty stuff that gets in there. And it doesn't have new properties from purified gold. Sugar is a compound because it has new properties. A person is a hetero mixture because it has cells. Oh no. Classified by picture. This is an element because it's all one type of thing. This right here is a compound because it's touching. If it touches, it's a bond. Compound, and this is a diatomic element. Okay? So this is a mixture. This is a mixture, same deal, right? Doesn't matter if they're equal numbers, they're still mixtures. This is a hetero mixture. That's one type of atom, that's the other type of atoms. And it's hetero because it's in layers. So hetero can be layers. Oh, why did I write that down? This is a pure element. This is a mixture. I'm not going to make you figure out what the gases are and count the different things of two elements. This is a compound. This is a pure compound. And the reason why it's a pure compound is those are touching, right? This is a homogeneous mixture. This would be an alloy of two elements, right? Boop, boop, boop. They're not touching, that's why it's a mixture. Review. Hey, we're here. So bonds make molecules. Mixtures have blended properties, but compounds have new properties. Separate mixtures by physical properties. Oh, we don't have to do that. Woohoo! Whoops, meant to chop that off. And we're all done. Toodles.